Welcome once again to another option video. This is the third video in the option pricing model sequence, and tonight I'd like to look at the third characteristic of a valid option pricing model, and this is going to be from the perspective of both calls and puts. So let's start with calls. So from the perspective of calls, it is necessary that our option pricing model be such that the market price of a lower strike call is never less than the market price of a higher strike call. Okay, that can never be the case. Okay, just so you understand, the price of the lower strike call could equal the price of the higher strike call, and that will only be true when the value is zero. Very, very close to the end of the option's life for calls that are out of the money. Okay, but the price of the lower strike call can never be less than the price of the higher strike call. And again, why? Well, it's obvious. We like to pay lower prices. So a call gives us a price that we're guaranteed to be able to pay, and we like to pay low prices, much more than we like to pay high prices. And so, again, the equilibrium condition for calls is that the price of a lower strike call can never be less than the price of a higher strike call. Okay, so let's that's the condition, and let's see what happens when it's violated. So let's talk about a call with a strike price of 24. Let me just write this a little differently. Okay, a call with an exercise price of 24, and then another call with an exercise price of 25. Okay, and a little subscript here means we're looking at their prices at the same point in time, a point in time I'm calling date 0. And let's say the price of the 24 strike call is $1.20, and the price of the 25 strike call is $1.30. Okay, so think about what we have here. We have the price of a 24 strike call. We have the price of a contract that enables us to be able to pay $24 a share, costing $1.20 on a per share basis. At the same time, excuse me, that a call option that guarantees you the right to pay 25 is more expensive. Okay, so at first glance, it doesn't appear appropriate, and it's not. But let's just prove why. In other words, what would you do if you saw these prices? Well, when you saw those prices at date 0, okay, you would, of course, sell what's overpriced and buy what's underpriced. Okay, and so the 25 strike call, it appears to be overpriced relative to the 24 strike call. So what we'll do is we'll sell one call with an exercise price of 25, and we'll ignore the bid-ask spreads and just assume 130 is the price. And therefore, when we do this, the cash flow that we get is for the whole contract $130 positive, an inflow of $130. And then at the same time, we'll buy the call with a strike price of 24, and that's going to cost us $1.20. Okay, and therefore the net cash flow upon initiation of this position is an inflow of $10. Now look at what we have here. We are long a lower strike call, short a higher strike call. This is a call bull spread. Okay, just note that this is a call bull spread. Okay. Excuse me. All right. So, well, let's look at our spread, and I guess we'll keep it in the individual pieces, the legs of the spread, the 24 and the 25, and let's look at the value under the assumption of certain prices at option expiration, prices of the underlying stock. Okay, so let's look at some of those. Let's look at, let me see. First, I'll indicate that we are short one call with an exercise price of 25 and long one call with an exercise price of 24. Okay, and then let's look at the prices. Let's look at 23, 24, 24.50, 25, and 26. So these are stock prices at option expiration. Okay, that's what we're looking at here. Okay, and then let's just see the value of our position and calculate the profit. Okay, and I'll note that if the stock price is 23, both of the calls are out of the money because the right to pay 24, the right to pay 25 are both worthless at option expiration, or maybe a minute before option expiration if the stock price is 23. So the value of both of these at 23 is 0. Now again, it's kind of silly, but it's helpful. We own this call, and it's worth nothing. So we're not going to be able to sell it, but it's kind of like we're selling it for nothing. So an inflow of 0. Again, I know that 0 does not have a sign, but this is just meant to help us understand what's going on in other circumstances. On the other hand, the call that we're short, the 25 strike call, expires worthless, and that means since we sold to open, we will not be required to buy to close. So that means we are effectively having to pay 0. Now again, minus 0, I know it's ridiculous, but it's kind of a neat way of looking at it. And then don't forget our net credit at position initiation. Okay, and that was this $10 here. So there's the 10, and put a plus sign there, and then the profit. Well, that's 10. We're up $10. What if the stock price is 24? Well, once again, both these options expire worthless. This, our short option is at the money, and at the money options at expiration are worthless. And, the 24 strike option is at the money, and so this option expires worthless. The 25 strike is out of the money. It also expires worthless. So we have 0 here, 0 here. And again, we have a plus 10. And so our profit is $10. Again, what if the stock price at option expiration is $24.50? That's interesting. The 25 strike call that we're short still expires worthless because the right to pay 25 when the market price is $24.50 right at option expiration is 0, so that's 0. But the right to pay 24 when the market price is $24.50, and we're long that one, it's worth 50 cents a share or $50 for the contract. Okay, so that means we can sell it. We're ignoring bid-ask spread. We're ignoring commissions, and so it's worth 50. We assume we'll sell it for 50, and we also get to keep the $10 net credit from the initiation of the position. So here we're up 60. Oh, very interesting. And then about the 25 strike call, if the stock price at OE is 25, well then our short position is at the money. It expires worthless, but the 24 strike call that we own is worth $100. So that's worth 100. We sell it for 100, and then we still get the $10, and so now we're at 110 plus 110. I'll try to put a delineator up here in pink. Starts to run together a bit. Okay, and I'll put another one here. And now let's look at the case when the stock price at option expiration is 26. Well, the 25 strike call is worth $100. We're short the call, so that's $100 we have to pay to buy to close. So we're going to spend $100. Fortunately, the 24 strike call that we own is worth $200, and we assume we sell that a moment before expiration, and we get That's a plus sign. Plus 200. We still get to keep the credit at 10. So once again, plus $110. Oh, so even if the stock price at OE was $100 a share, we would still have a $110 profit. And even if the stock price at OE was zero, that way down here is zero, we'd still have a $10 profit. So our profits are running between $10 and $110 no matter what. No matter what stock price is at option expiration, our profits are positive, running from $10 to $110. If we were to graph this, much like we graph call bull spreads, okay? Now let me just show you, in orange, I'll show you a typical call bull spread diagram. Would look like this, okay? You know, we got areas of loss down here, areas of gain up here, and that's what they look like. But in this case, and I'll do this one in purple. In this case, the worst that can happen is we make $10, and the best that can happen is we make 110. So this profit diagram here, I'll keep the strikes the same. Looks like this. So you see it, the purple profit diagram is everywhere in the first quadrant, and the first quadrant is positive profits. Remember, we have profit on the vertical axis and stock price at option expiration on the horizontal axis. Okay, so this is an illustration. This purple line is an illustration of the current circumstance. And in other words, if the market price of a higher strike call was greater than the market price of a lower strike call, you would set up a call bull spread and you would have a profit diagram like this one, and you could never lose. Now, how many times would you do that? Well, you'd do it as many times as you could. But now let's think about how good markets behave. Well, we are selling the higher strike call and buying the lower strike call. So what we're doing is we're driving down the price of the higher strike call, and because we're buying the lower strike call, we're bidding up its price. And eventually, this value right here, that's the net of those two, is going to become negative. Eventually, negative. And if it's negative, then we're in the normal scenario, the normal behavior of profits as a function of stock price at expiration, something like we see here in the orange profit diagram. Okay, so there we go. There's our discussion of call options. And again, the rule for our option pricing model is that the price of a lower strike call can never be less than the price of a higher strike call. Okay, now let's look at this same issue from the perspective of puts. Okay, so let's look at this from the perspective of puts. So now we're going to talk about puts. So the idea here is that the price of a put, P stands for put here. Okay, so we have a lower strike put and we have a put with a higher strike. Now stop and think, what has to be true? Because we know they could be equal. Okay, and I'll put it here. The price of the lower strike put can equal the price of the higher strike put if they're both zero. That's the only time that would be okay. But generally speaking, what is the relationship between the price of a lower strike put and the price of a higher strike put? Well, generally speaking, the price of the higher strike put, okay, is generally higher than the price of the lower strike put. Why? Because when we own a put, we're locking in a sell price. So excuse me, we're not locking in. We have a price that we're guaranteed to be able to use to sell stock at, and we would rather sell at high prices than at low prices. Okay, so what's the relationship? Well, then we can say the price of the lower strike put can never be greater than the price of the higher strike put. Okay, so this is our condition. Okay, I'll circle it in orange. Okay, this is our condition for puts. Okay, the price of the lower strike put, the market price of the lower strike put in equilibrium can never be greater than the price of a higher strike put. Okay, now almost always, okay, the price of the higher strike put will be greater than the price of the lower strike put. This is almost always the case. Okay, however, sometimes we have this. And so the way you kind of summarize that in a sentence is as I've done here. We say the price of the lower strike put can never be greater than the price of the higher strike put in equilibrium. That's the condition. Okay, well, let's examine a circumstance where that condition is violated. Okay, so we'll talk about a put option now. I'm going to red. So let's say we have a put with an exercise price of 33, and talk about its price right now, and a put with an exercise price of 34, and talk about its price right now. Okay, so let's make the price of the lower strike put higher than the price of the higher strike put in violation. So let's make this 250, and so the right to sell at 33 is 250. Again, the right to sell at 33 is $2.50 per share, or $250 for the contract. And let's just assume that the price of the put that gives us the right to sell at 34 is $2.20. Okay, let's just pretend. Okay, we're going to assume this is the case. Now, of course, this is not an equilibrium. Okay, the condition that I've shown here is not an equilibrium. I'm just showing you a violation of this rule here, and showing what we do when this is the case. Well, in relation to one another, it appears that the lower strike price put is overpriced. Okay, overpriced, and therefore this is underpriced. Okay, and so what do? We like to sell what's overpriced and buy what's underpriced. So at date 0, I'll go back to blue. At date 0, we will go long one put with an exercise price of 34. Okay, and the cash flow, that's date 0 there, and the cash flow associated with that is an outflow of $220, and we will at the same time go short one put with an exercise price of 33, and that will result in a cash inflow of $250. So here we see our net cash flow is a credit, so we've got a net credit from setting up this position, this compound position, of plus 30. Now look what we have here. We're long a 34 strike put and short a 33 strike put. Okay, and this is a put bear spread. This is a put bear spread. Okay, now, okay, so we get a net credit when we set this up. Well, put bear spreads in equilibrium, you may remember, are net debit spread. So the fact that we're getting a positive cash flow when we initiate this position is quite unusual, and that's our point, that we're showing that this can't hold. Okay, now let's just go through the proof of why that's the case. So we're going to look at some prices. Okay, well, first of all, we're going to note our positions. We're long one put with an exercise price of 34. We're short one put with an exercise price of 33. Okay, and let's look at the prices. Let's look at 32. These are stock prices at option expiration. 33, 33.50, 34, and 35. So again, these are stock price at option expiration assumptions. That's what these are. Okay, and here we go. Well, if the stock price is 35, I'll start up here. If the stock price is 35 at option expiration, well, the right to sell at 34 and the right to sell at 33 both expire worthless. So 0 and 0. Again, we bought this one, so it's kind of like we sell it for 0, and we sold this one to open. I'm sorry, put a plus sign on this. Okay, we bought this one, so we bought to open, we sell to close, we sell it for nothing, and now down here with the 33 strike put, we sold to open, so we buy to close, and so it's like we pay nothing. So again, this, I'm well aware that 0 doesn't have a sign. This is just meant to make things kind of neat, easy to understand. Okay, but then I got to remember my net credit. So I received $30 when I initiated this position, and then my profit, if stock price is 35, is going to be 30. Okay, what if stock price is 34 at option expiration? Maybe use a different color, make them. Okay, what if stock price is 34 at option expiration? Well, this put is at the money, it expires worthless. This put is out of the money, it expires worthless. So 0, 0. And we still get our net credit of 30. And our profit is 30. Okay, interesting. What about 33.50? 33.50 is interesting. We'll do that one in blue. Okay. So if stock price is 33.50 at option expiration, this 33 strike put, the right to sell at 33, is worthless if the stock price at OE is 33.50. So I'll put a 0 there. I don't have to buy to close. So I'll put a 0 there. But the one that I own, the right to pay 34, the right to sell at 34, if the stock price is 33.50, it's worth 50 cents a share, or $50 in total. And so I make $50 then. Its value at option expiration is $50. So I'll sell it and get the $50. I also received $30 when I wrote, when I opened this position up here. And therefore, I've got $80 profit. Well, what if the stock price at option expiration is 33? Well, in that case, this put that I'm short is still worthless. Okay, it expires worthless, so at the money it's worthless, so I put a 0. And the right to sell at 34 that I own is now worth intrinsic value, which of course is the maximum of x minus s, or 0 times 100. X minus s is 34 minus 33 is 1 times $100. Is 1 times 100, or $100. So there's my plus 100. There's my 0. There's my plus 30, the credit I received when I set up this put bear spread, and therefore I make $130. And then let's look at a price of 32. Well, if the stock price is 32 at option expiration, then let me see. The right to sell at 34 is worth $200. Okay, the right to sell at 33 is worth, well, the intrinsic value. The right to sell at 33 when the market price is 32 is $1 a share, or 100 per contract. But I sold open, so I got to buy to close. So that's $100 that I have to pay. Okay, so notice that this plus 200, this minus 100 still nets 100, and then I got my net credit of 30, and therefore a profit of 130 again. So even if the price was 0 at option expiration, my profit would still be 130. And up here on this end, if the price were 100 at option expiration, my profit would still be 30. Okay, so very interesting. We've seen that we don't get any circumstance. There's no scenario. There's no stock price at option expiration that results in us losing money. And so that means that that this is a pretty good deal. And we might, let me graph the profit diagram for you. So again, we've got profit here and stock price at option expiration here. And so there's 33 strike, there's the 34 strike. Let me just draw a normal put bear spread for you. It would, I'll keep it in, no, I'll change it, I'll make it in orange. The normal one would look like this. Okay. We've got some values that are negative, some values that are positive, some values, one value that's break even, and that's a typical case. But this one up here is quite interesting because we never lose. As a matter of fact, the lowest our lowest profit's 30, our highest profit's 130. So I'll put this one in purple, and it's going to look like this. Okay, so this purple diagram is the profit diagram that we now have, and it's actually quite interesting. We we never lose. Now, how often would you like to do this one? Well, you'd like to keep doing it over and over and over. You'd like to repeat it infinitely. But let's think about good markets. What do good markets cause to happen? Well, you guessed it. Since we're buying this put, we're bidding up its price. And since we're selling this put over and over, we're putting downward pressure on its price. And as the minus 220 starts to become minus 230 and minus 240 and minus 250, and the plus 250 starts to become plus 240 and plus 230 and plus 220 and plus 210, eventually this number right here, guess what? Becomes negative, right? It becomes negative, and once this number becomes negative, we're back to the normal position right here for the put bear spread. And there are many equilibrium price combinations for the 33 and 34 strike put that would allow an equilibrium to develop. But we know what's not an equilibrium, and what's not an equilibrium is what we showed here, and what I showed you here was why it's not an equilibrium and how we'd profit. And then the profit diagram is nice to see. And then I also reviewed what happens with the market prices, okay, and how the market adjusts and pushes toward an equilibrium where, again, the put bear spread becomes a net debit spread as opposed to, as it was in this case, a net credit spread. One other thing, notice that the maximum value of this spread that we're setting up is the difference in the strike prices. 34 minus 33 equals 1 times 100. Okay, so the maximum possible value for that spread at option expiration is $100. $100. And you remember that from some of the earlier videos, but I just want to remind you of that. So, again, what I've showed you here is the third characteristic of a valid option pricing model is, for calls, that the price of a lower strike call can never be less than the price of a higher strike call in equilibrium. And for puts, the price of a lower strike put can never be greater than the price of a higher strike put in equilibrium. That's all I have. Thanks for watching.